Right, afternoon everybody. I think we'll kick off. So yeah, this session is on VCF Networking, still known as NSX. For how long I don't know, but it's still in the title there. As Joe mentioned earlier on, the NSX product used to come with all the networking and the security elements built into the product itself. We've now split out the security elements. So the security elements from a VCF perspective are add-ons to the product, but in terms of the networking, you get all those component parts as part of the VCF product itself. So a little bit of background. My name's Richard Jones. So I'm a solutions architect in the VCF networking team. So I suppose I'm a specialist. Been at VMware nearly 10 years. Came in to do PSO in terms of delivery of NSX and certainly NSXV around that time. But now moved into sort of a pre-sales role, sort of supporting the core teams. So that's just a little bit on me. Anybody running NSX at the moment? Anybody deployed NSX? So you've got a few people. Okay, cool. So the first bit, as I say, of the presentation, you might know a lot of the detail, but then as we go further on, I'll talk about some of the things that have come in the 4.x release of the software. And then I'll just cover a bit on VPCs and just do a couple of demos at the end. So if we look at, I suppose, private cloud and where VCF networking sort of fits into that, around sort of simplicity with NSX and obviously how we sort of build out, I suppose, VMs today, but how we can utilize NSX. We can do sort of building out sort of repeatable patterns. So from a network and a security perspective, we can build those sort of repeatable patterns as part of a deployment of an application or a set of VMs. Availability, this is really where we talk about sort of disaster avoidance or disaster recovery and where we can sort of do VM mobility across a data center or between multiple data centers and sort of retaining things like the IP address of the virtual machines as they move between those locations. Then scalability is around, I suppose, pooling resources together. Really how we sort of, rather than having separate siloed systems, we can actually pull all of that capacity together and then actually use sort of logical separation within that pool of capacity to separate them out into different sort of requirements, whether that's sort of things like test and dev, pre-prod, production. And then consumption, really. It's really how we consume, I suppose, NSX. Ultimately, I suppose, NSX has a front end, has a UI, so you can log into it, you can configure it. But actually, I suppose, really the consumption is really how we can sort of drive maybe through API, through automation, and actually sort of get some efficiencies there when we're sort of consuming the product itself. And then we've got support for things like Ansible and Terraform in there as well. And then I'll talk a little bit more detail around sort of projects and VPCs towards the end of the presentation. So this statement here is there is no cloud without SDN. So certainly from a VCF perspective, obviously we've got a full stack. So we've got compute, we've got storage, and we've got networking and security. And ultimately, if you look at sort of hyperscalers and how hyperscalers deliver services out to you in terms of creating sort of VPCs and VNets, all of that is delivered in software, right? So there's no physical tin that somebody then has to go and configure to provide you basically with that sort of set of infrastructure. It's all delivered in software, and that's really where we're sort of driving, I suppose, from an NSX perspective as well. So just some of the key requirements, I suppose, around SDN, and I suppose where VCF networking sort of maps into that. It is about sort of providing, I suppose, that network virtualization layer, layer 2 to layer 7 services, virtual private clouds, and then sort of using things like, as I say, the distributed functions around the networking, the security, the routing, and then adding in things like the advanced sort of load balancer or the AVI product, as it's now been renamed back to. And then things like federating networks and then providing sort of security across a location or across sort of multiple locations. So just sort of, I suppose, taking a little bit of a step back in terms of what NSX is. It is, as I say, about building sort of a software-defined data center with actually minimal or no changes to the physical network, providing sort of that distributed routing capability, and then building consistency across the data centers that you're operating. Also sort of for Kubernetes as well. So providing a CNI into Kubernetes so we can still use NSX for all the networking and security components. Using VCF network operations, which was previously called VRNI, it's been called a couple of other things since, to provide sort of that monitoring of the actual NSX platform itself, also helping you to sort of plan security, and also sort of do day two sort of operations and troubleshooting as well around the product. And then if you're looking at, I suppose, migrating workloads from legacy environments into an NSX environment, into a new SDDC, then we've got HCX to support that. And then, as I say, the add-on really is around the DFW and the advanced threat prevention capability. So that's really, as I say, where the vDefend product is added into NSX and licensed into NSX as an add-on, can provide those sort of capabilities. So from an NSX perspective, in terms of how we deploy NSX, we start with the physical infrastructure. So we need a set of switches to provide connectivity between our hosts. Ultimately, the requirements of that physical infrastructure, obviously there'll be a number of VLANs that you need to stand up the environment, but really it's IP reachability between the hosts and then support for a sort of a larger MTU, because we're going to use overlay networking to provide the layer 2 stretch where we can have our VM sitting on that same layer 2 network within a data center or across multiple data centers. It's then really about preparing the hosts for NSX, building this NSX platform across the top, and then using the virtualization layer of NSX to start building out our network constructs. By that I mean, as I say, we can pull all of that capacity together, and then we can start building out different environments as the needs arise. And all of this really sits on sort of this virtual distributed switch. So within your environments today, you're probably running virtual distributed switches, not standard switches. We're basically adding capabilities into the kernel. So we're adding the distributed routing, we're adding the distributed switching, the firewalling capability, and then, as I say, we've got integrations with sort of load balancers as well. And then obviously sitting on top of that, we've got our workloads. So our workloads obviously connect into the virtual distributed switch over a sort of a virtual wire, if you like, and then that's really where we can layer in those services. And then, as I said earlier on, we can obviously make containers as well, sort of a first-class citizen of the environment as well, with our integration with the likes of sort of Antrea and the CNI there. So that's really, I suppose, in a nutshell, what NSX is, and obviously where it provides that layer of abstraction away from the physical infrastructure, and obviously where we can sort of start automating the deployment of workloads. So if we look at, as I say, the overlay, and this is really, I suppose, fundamentally what NSX provides in terms of that layer 2 stretch, it is a layer 2 stretch over a layer 3 network. Okay, so we're not asking you to provide layer 2 networks everywhere. This is really layer 2 over layer 3. So I suppose in this example, and there's a bit of animation in here, you've got a couple of VMs within a rack. Obviously, this is sitting on subnet A, so obviously a different IP address range to rack 2 with subnet B. As I say, this could be within the same data center, or it could be across multiple data centers. We've got two VMs. They're sitting on the same IP subnet, as you can see. What we'll do is encapsulate the traffic that the VM1 wants to send in what we call Geneve. So Geneve basically is the tunneling technology that we use, very similar to VXLAN if you've come across VXLAN. But that's ultimately what we'll do. We'll build a tunnel between the two VMs to enable them to communicate on the same IP segment. And you can see at the bottom there, we've got effectively a control plane in NSX that controls or understands where the VMs are sitting in terms of the hosts, and understands where the tunnel endpoint is for each of those hosts. Now we've got things like DRS and HA configured, so we've now lost host 3, our VM is now spun up on host 6. What we'll then do is recreate that tunnel between the VM1 and the VM2, but obviously across racks, across data centers to provide that connectivity. So obviously those two VMs are now sort of still sitting on the same layer 2 network. There's been no change to the IP addressing of VM2. It's still sitting on the same IP address range, and obviously they're able to communicate. And basically we've updated our TEP table as well. So we now know through the control plane that the MAC address of VM2 is now sitting at TEP B3. So really it's about, as I say, from an NSX perspective, about providing overlay networking, removing the need to make changes to the physical infrastructure on a daily basis. Ultimately, the physical infrastructure should be there to sort of push packets around, but actually with minimal changes to the environment itself. Distributed architecture, so obviously eliminating things like hairpinning. So, for example, if you're not running NSX today and you've got two VMs sitting on the same host, but on different port groups, to enable those to communicate, they're going to have to exit that host, hit a top of rack switch, firewall, router, for that traffic to potentially return back into the same host. So obviously with NSX and actually putting routing in the hypervisor at that kernel level, we would avoid that. So ultimately the routing would be done within the host, and obviously there's no need to go out to the physical infrastructure to get that traffic and that communication between the two VMs sitting on two different IP subnets. And then ultimately, I suppose, simplifying the deployment of networking infrastructure. So actually trying to do that through automation. As I say, there is a UI, and you'll see the UI in a bit, but really it is about, I suppose, how you can automate the deployment of networks and not have to do those tasks manually. So this is really a good example, I suppose, of where NSX, without NSX on vSphere. So again, we've got a couple of racks, we've got a logical view of what we want to set up, a couple of VMs on one subnet with a load balancer. We've then got an internet connection through the router, and then we've got the other VM3 sitting on a different subnet. So what you'd have to do is you'd have to get the VMware admin to deploy the VMs. You'd have to configure the VLANs on the host, so obviously you'd have to configure some port groups on the host. He would then need to speak to the Cisco guy or the networking guy, whoever he might be, to configure the VLANs, obviously those uplink VLANs. He would then need to extend those, obviously, to the physical switches, attach the VLANs to the router, configure the VLAN interfaces on the router. You see where we're going with this. Configure the BGP. We would then need to speak to the firewall person, right? So we'd obviously need to speak to them to obviously make the changes to enable our application to communicate. Then potentially somebody who administers the physical F5 or the physical load balancer. Ultimately, so we need 4 personas to ultimately enable us to deploy an application and get that application communicating out on the network. And obviously this takes time, right? So ultimately what I'm saying is here, I've spoken to a lot of customers over the years where it's quite quick to deploy a set of VMs or an application, but actually you then need to go to networks and security, raise some changes, get them to make the changes, and it can take weeks to do that, right? It could take weeks to get that done. If we add NSX into the mix now, what we'll do is we'll ultimately get the VMware admin to deploy the VMs. He can then configure all of the required connectivity through a single API call. So basically within NSX, we're going to create that construct. So we're going to create the logical switching, we're going to create the logical router that's going to sit there. We've got a peering to the outside world already. It's there. It was pre-configured sort of on day one. So everything here is now delivered through an API call, and it takes basically minutes to do that, to get that stood up. And that's really, I suppose, what it says there. It is what network virtualization is, and that's ultimately how the private and the public cloud will operate, right? It's all delivered in software. It's all done through an automated process. And ultimately, as I say, it takes minutes to deploy that and get that up and running. In terms of the infrastructure itself, as I said earlier on, it is all embedded into the hypervisors themselves. So it's a scale-out architecture. So every time you add a host to an environment and you prep it for NSX, you're getting that additional capacity. So you're going to get an additional capacity around the distributed routing, the firewalling, and the switching. Okay, so you can see that it scales. From a security perspective, we see all the inputs and the inbound and the outbound connectivity. So there's absolutely no blind spots, even if VMs are moving around because of things like HA and DRS. Then ultimately they're secure as they move around. And then we're sort of application aware because we have the sort of the rich context around the VMs. We're using things like VMware tools. We understand sort of what the VMs are, what the operating systems are. Then we can build things like IPS IDS rules for particular workload types, rather than having to push all of the workloads through all of the IPS IDS signatures, for example. We can tailor the configuration for that. And then it is centrally managed really across the entire network, from basically the NSX manager or set of global managers, however it's configured. They then pushing policy out to the environment itself. And then, as I say, what that really gives you is a lot of embedded services. Now, I'm not going to cover all of those, but that's really what we've embedded into the hypervisor itself. from a networking perspective. Just really calling out, I suppose, obviously we'll build connectivity to the physical, and then we can support things like I said, the firewalling. We've got internal things like DHCP, and we'll come across that when we talk about VPCs and things. And then if you've got sort of legacy workloads, we can also bridge as well. So if there's a requirement to bridge physical to virtual, we've also got a capability around that. And then, as I say, this is really around the sort of simplified, I suppose, operation. So this is an example of where we're creating a network security policy. So you can see we're creating the policy, we're building the rules around the sort of the web and the app tier. We're going to allow HTTPS, and that's really done through, as I say, an API call. So we're basically pushing that through API to actually make that change. And then, as I talked about it earlier on, this is really VCF network operations, providing the analytics, the troubleshooting, the operationalizing of NSX, make sure that NSX is functioning as it should be. And if there are any anomalies, then this product will sort of call those out, and then obviously you can then look to remediate those as well. So they sort of go in hand in terms of the products themselves. So this is really just an example where we're going to sort of deploy our application. We're then going to put some storage on the back of that, which would be vSAN. We then create that logical networking up to the top of rack, to the physical device itself. We can then put security on those VMs, so we can put security right down at the VNIC of the virtual machines themselves. We can then orchestrate that through, I'd say I talked a lot about API, but we've also got ARIA automation as well, where you can build blueprints. You can offer those blueprints out as sort of self-service items and a self-service catalog to people. They can then go in and request those, but ultimately it will just repeat that sort of deployment. You can put approval processes in there as well if you wish to do so, but it is about delivering, I suppose, the infrastructure in code. And then also the monitoring capability, so things like the SDDC manager, and then we've got some capabilities within NSX itself, so you can sort of realize what your infrastructure that you've created looks like and do some fault finding and some troubleshooting. And then NSX is obviously responsible for the networking part. The security is sort of optional, and then obviously you've got the orchestration and the monitoring piece as well. And I'd say that's really, I suppose, what sort of software-defined networking is. Just going to cover a couple of the use cases. So there is a session on security, and it's on sort of vDefend. So if you get a chance to go to that one, I definitely do that, because it really just, I suppose, adds to what I'm talking around NSX and obviously the security elements around, let's say, the distributed firewall, the layer 4 to layer 7 firewall, but also the IPS IDS capability and the advanced threat protection. So this is really where we are providing that micro-segmentation. You've probably heard the term before, but it really is about providing security right down at the VNIC of the virtual machine. So because we're in the hypervisor, we can absolutely put a security wrapper around every single VM. If that VM's got multiple NICs in it, every single NIC within that VM will basically get its own security policy. As I said earlier on, obviously support for things like DRS and HA. If our VMs are moving around our environment, then the security policy follows the virtual machine. If the virtual machine or the application goes away, then ultimately, do you know what I mean, those rules are removed from that application. And then we can secure end users as well, so there's some capabilities in and around there and around sort of identity-based firewalling. And as I say, DMZ Anywhere is because we can put that wrapper around the virtual machine. We don't really have a concept of a DMZ sort of sitting out to the side, because we can absolutely do that within software and within NSX itself. And then automation, as I say, really talked about this already, around how we can build out, I suppose, things like multi-tenanted infrastructure. So actually having NSX sat there, being able to provide the networking and security, but abstracting that out into some sort of cloud management platform. So whether that's ARIA automation, or whether that's through Ansible or Terraform, it is really about how we can sort of use NSX to, as I say, support that sort of multi-tenanted sort of function. Reduce the risk of human error. So as I say, we can put everything into blueprints. We can then basically request those. They're repeatable. There's nobody going in and making manual changes to the platform, the system, when we're doing everything sort of through automation. And then really the third is around sort of multi-cloud networking. So providing the ability to stretch your data center between one location, multiple locations, providing sort of support for use cases around data center extension, where we can stretch that layer 2. We can potentially have the application running active-active at both sites. Also supporting disaster recovery as well. So if you're running active-passive, obviously ultimately moving the workloads from one location to another. Obviously if we lose the sort of protected site. And then I suppose key to any of that is around sort of the workload mobility, the ability to retain the IP address of the virtual machine. So rather than having to, maybe you've lost your primary site, bring up the secondary site, re-IP address your applications and your VMs to get yourself back up and running. If we can retain the IP address, if we can do the whole dynamic routing piece as well, so where we're routing at both sides but preferring a particular site, if we can actually just swing that across, the dynamic routing sort of takes over. The VMs are then in the second location because we've used the tools to get those VMs across. Ultimately, it's going to make your return to sort of normal much quicker, or certainly a return to basically getting workloads back up and running in a much quicker fashion. Just going to cover a couple of things on VCF, NSX 4. This is sort of, some of these features have come in sort of the 4.0, 4.1, 4.2 release. This one I wanted to call out actually sort of in terms of 4.2. The NSX has a native load balancer built into it. And we've talked probably about 2.5, 3 years about removing the native load balancer from NSX. We've obviously supported the use where we said to customers, actually, you should move to AVI, the NSX Advanced Load Balancer, for sort of your server load balancing. What we've now done is sort of pivoted a little bit in 4.2 in that we're actually now not depreciating the native load balancer. There's just an entitlement change for that load balancer. Anybody using the native load balancer? Anybody use? So yeah, okay. So yeah, so there is an entitlement change for that. So basically it is staying, but obviously there is only a couple of sort of corner use cases really where that native load balancer should be used. And if you want to move, if you're currently using load balancing services, things like sort of SLB and GSLB, then we've got the AVI product to support those use cases as well. In terms of the 4.x releases, a couple of things we'll call out. Virtual private clouds, I'm going to show you a demo and we're going to talk about those in a bit. Stateful active-active edges. When NSX is deployed, generally we're deploying what we call edge nodes. And then sitting above the edge nodes is a logical router, so what we call a tier 0, which provides connectivity from the virtual to the physical world. What we then tend to do is when we design these is we're running multiple edge nodes and then we're running just routing within that domain, and then we're running things like equal cost multipathing, so we can get basically the performance out of multiple edges where we receive multiple default routes and then we send out multiple default routes, and then we've got a lot of asymmetric routing going on. What I see asymmetric routing doesn't really consider is stateful services. So what we've now done is, as I say, as part of one of the 4.x releases, is we've now added a stateful active-active edge. So where we can still have edge nodes deployed, we can still run ECMP, we can still run the performance and get the throughput across multiple edge nodes, but we can now also run firewalling capability on there as well, and things like NAT as well in a stateful service. Okay, and then really things like TEP groups as well. TEP groups are going to be quite important for performance of NSX, rather than having to look at the way which currently works with TEPs, tunnel endpoints, is it's sort of a one-to-one mapping. What we're now doing is we're grouping TEPs together so we'll get better performance out of a group of TEPs rather than actually pinning traffic to a single TEP. Now that's been delivered in the edge nodes, but it's also coming for the hypervisors as well, but it's not actually in the support for hypervisors as well. But it's really about, as I say, increasing the performance of NSX and gaining some efficiencies there. Cool, so just going to talk about, as I say, multi-tenancy. So multi-tenancy, as I say, is fairly new. It's been delivered in 4.x in a couple of different ways. One is around what we call projects, and then we've got VPC. So if we just look at, I suppose, take a little bit of a step back and look at some of the concepts. When we talk about multi-tenancy before VPCs and projects, what we'd have to do really if we wanted to sort of, I suppose, help customers do some sort of multi-tenancy would be to provide isolation using either a gateway firewall or a distributed firewall. We also would suggest or create separate logical environments. So we might stand up a VRF-A and a VRF-B. We might stand up separate tier zeros where you might actually interface in from a physical in through a VRF for production, a VRF for pre-production, a VRF for test and dev, and provide tenancy and separation in that way. And then things like, I suppose, around sort of tenancy, and I said earlier on, if we talked about tenancy with NSX before 4, we would suggest obviously you'd put in a cloud management platform and build that abstraction layer, so you'd actually talk to area automation and then do all of your work within there as a tenant of the platform, and then it would then push the configuration down to NSX. So you wouldn't drive NSX from the UI or the API directly. You'd have an intermediate sort of system to do that. Or you'd have separate NSX managers, so a separate deployment, right? So you might have a separate deployment for different types of workloads. And then logs and alarms, it was just literally single alarm, single logs, basically, because it's a single NSX platform. What we've now done, as I say, we introduced projects first. So projects are created by the enterprise admin, but you can then delegate out basically a portion of NSX. So you could log in as a project admin and you get access basically to whichever project you're allocated to. And then within that, your own enclave, you can build infrastructure within there. So you can manage your own infrastructure, you can create your own routers, subnets, networks, but actually still, the platform is still protected because obviously you don't have access as the enterprise admin. And then you get your own alarms and your own sort of log labels as well as part of that. And then also things like quotas. So obviously what we don't want to do is give people access to the system, but allow sort of free reign to do whatever they like. What you can do from an enterprise admin perspective is you can basically restrict how many logical switches they create, how many subnets they can create. There's lots of different things you can restrict. So obviously the projects can't go rogue and just start building out whatever they want. There is some boundaries in place to actually protect that. And then a step further down is we've introduced sort of VPC. So these are not dissimilar, obviously, to VPCs in an AWS or a VNet in Azure, right? So where we're building these additional enclaves within a project and then giving access, or developers potentially access to those VPCs so they can go in, they can create their application, they can connect their application to their own logical switches, they've got their own routing inside there, subnets obviously they can talk to, and then they can change their security policy, so they can build their own distributed firewall capability around their own VPCs. So this is really, I suppose, just the definition of what a VPC is, and obviously in the context of VCF. Okay, and you'll get all these. I think you're going to get the slides anyway. So yeah, this is really, I'd say, where we're building out these virtual private clouds, and this is really what it looks like conceptually, where we can have isolated subnets, we can have public subnets which are accessible from the outside world, and then we've got private subnets as well. And then, as I say, sitting in the middle, we've got a router which will obviously provide the connectivity and then talk out to the tier 0 gateway, and then the tier 0 gateways are responsible for passing the routing information out to the physical world. Yeah. So yeah, and then again, like I said, you can basically put firewall policy around those VMs as well. And so this will all be done from the VPC admin themselves. Now, even though the VPC admin can change his own policy, on top of that, there is still the policy that's created by the enterprise admin as well. So that rule base is still adhered to as well. So as the enterprise admin, you might give them access to shared services, but you also might restrict access to other things sitting outside their VPC out in the virtual world or out in the physical world. So you still have a level of control as the enterprise admin to what they can and can't get to. But within their own little enclave, they can obviously configure policy and security as they wish to do so. So just got a couple of demos. I think we've got a bit of time. Yeah. So this is quite basic, but I think you'll get the picture. physical router at the top. We've then got a tier 0 router that's deployed, and as I say, that provides the connectivity between the two environments. We've then got a VPC called Finance, or Fin, which is part of the Finance project. And then we're going to have a developer. So developer 1 basically is going to have access to that VPC, and then you'll see that he can obviously go in and make sort of changes and configure his environment. So if I play the lab, I might just pause it occasionally, just so we can talk about it. So this is logging into vSphere as the administrator. So you can see that obviously I've got full access to the environment. You can see underneath here, got a number of VMs. You can see we've got a Finance DB and a Finance Web 1. You can then see I've got a folder called VM Finance, and you can see there's some permissions associated to it. So it's basically talking to LDAP, and you can see that the role is a developer role, but actually you've got a group there called Dev Finance. And then within the Dev Finance group in AD, we've got one member, which is Developer 1. And then if we log into NSX, so this is logging in as the enterprise admin, so this is top level login. I'm just going to sort of show you around some networking. You can see the network topology here. And you can see that we've got a tier 0 gateway at the top, so that connects to our physical, so obviously you've got some BGP peering going on there. We've then got a router that's created inside oh, sorry, I should have paused that. I've gone too far. Let's get to the right spot. Yeah, so let me just pause it here. Yeah, so you've got the tier 0 router, which connects to the physical. We've then got, on the right-hand side, a T1, which was created by the enterprise admin. When you spin up a VPC, you get a tier 1 as well. So obviously we did doing two-tier routing. So we've got the tier 1 providing, tier 0 providing the connectivity to the physical, and then we've got these tier 1 routers which provide the connectivity within the VPC itself. Okay, so what you'll see in a second is you'll see, when I look at the tier 1s, you'll see the right-hand tier 1, but you won't see the left-hand tier 1 because ultimately it's hidden away, okay, because it's part of a VPC. So you can see there's the VPC, and then under that, we've got a couple of segments. We've got a DB segment and then a web segment, and then we've got a couple of VMs sort of sitting under there as well. So this is the tier 0 gateway. The tier 1, you can only see, as I say, we've got that tier 1 gateway that was created as part by the enterprise admin. If we now look at the project, because this is all pre-created, this is in there, we've got the finance project, and then we've got a set of parameters as well that are configured in here. You can see the associated tier 0 gateway, and then you can see the user group that we've specified. So you can see the AD group that we've specified that is going to be allowed to actually log in and look at this, this project and this VPC. And then under the project itself, you can see we can create some things inside the project, but we can also create these VPCs. So you can see here we've got the project, and then, as I say, to administer that project, we've got the finance group. And then we've got a couple of networks in here. We've got obviously an external block and an internal block. Connectivity, we've got our two subnets. We've got our Finance DB and our web, which are our logical switches. Then we've got network service, so we're providing some NAT on here as well, some SNAT. And then we've got a security policy as well. So this is really where the VPC owner can control their own security. So you can see here we've got a set of rules allowing our application to communicate. What we're now going to do is log out as the enterprise account, log in to NSX as developer 1. So you can now see developer 1's only got a subset of configuration, right? It can only see certain things. It can only see the finance VPC. And if we log into, because we've created as well that folder, and we've associated that folder to the finance group, If we log in again in here as developer 1, again, he's only going to see a subset of configuration. So he can only see the 2 VMs that are associated to that folder. He can only see that folder. He can only see his VMs. And from a networking perspective, because NSX is talking to vCenter, NSX has configured these, obviously, and offered these for consumption. So you can see that, obviously, if he went in and created another VM, he could put his VM on those 2 networks and only those 2 networks. So they're the only 2 networks to say that are available to him. So we're just checking here that obviously he can only see those two subnets. So yeah, and you can see where they've come from. You can see the project there is the VPC is there. What we're now going to do is say it's a pretty basic app, but we're going to connect to effectively our application. So we've got a front end and then we've got a database back end, and you can see we've got connectivity. And then all I'm going to do here is, as the developer, I can go in and then I can change my security policy. So this is outside of the enterprise admin. This isn't obviously now going to somebody to say, can you make changes? I'm actually, as a developer, doing this myself. So I've now pushed that policy where I'm going to drop the communication between the front end and the database back end. And then you can see we've now lost that communication. And then if I enable it, you'll see that the communication comes back. So yeah, and then we just refresh that and the communication is back. Okay. And then so the second demo that I'm going to show you, very similar in that we've got the top of rack, we've got a Paris T0. So that's always going to really be created by the enterprise admin, the T0. So enterprise admin will always create the tier 0. It'll create the peering to the physical, and that's basically fairly static. What we're then going to do is get the network and security admin to create a project, and then he's going to create a VPC. And then what we're going to do is going to, oh, that should say developer 2, mistake. But ultimately, once we've created that, we've then got a simple web application that the developer 2 can then go and administer. Okay, so we're just going to do the deployment, so it gives you an idea of actually what goes on during the deployment of the actual project and the VPC itself. So just going to let that run through. So again, we're just logging into vSphere and NSX as the enterprise admins. Then you can see we've got a user developer 2, but we don't have a group. Ultimately, I could go in and create a group. But what I'm going to do is I've got some scripts basically that enabled me to do this. So I just shrink that down, run the script which creates the AD group marketing. We're just going to go back to AD, do a refresh. You can now see we've got a marketing group, and then associated member, we've got developer 2 as part of that group. Go back to NSX. And again, I could log in here, and I could go through the UI, so obviously it's the UI. I can add a project, I can create all the parameters around that project, which tier 0 gateway I'm going to connect to, the edge cluster, all of the IP blocks that I might want to configure. So obviously I can do all of that through the UI. But again, in the interest of time and sort of saving, I suppose, 20 or 30 clicks, I'm just going to run a script that creates my project. So it's going to create my project, and it's going to create my VPC. So you can now see, do a refresh on that. You can now see we've now got this marketing project. Okay, so we've now created this marketing project. You can see obviously under there we've set a load of parameters. We've selected the networks and then the gateway and everything else. I can then select the project view, so I can go into the actual project itself. You can also see now I've got a marketing VPC. And you can see that obviously it's successfully deployed as part of that script. What I'm now going to do is go in and actually make some changes. Sorry, I could go in. Yeah, just need to close that off. Yeah. So what I'm now going to do, I think I'm going to check that I've now got also, as part of my deployment, I've now got a new NSX project, but obviously I've got no logical switches under it. I've got no networks to be able to connect to at the moment. And then you can see in here, sorry, second one along. Yeah, I've still only got the VM finance folder. So again, I'm just going to run a script that creates that folder within vCenter and then adds some permissions to that. So only the marketing group can actually gain access to it, and that will be developer 2. So if we just do a refresh on that, you can now see we've got marketing. There it is. And then what I'm going to do is, because I didn't have the time to deploy a virtual machine, I've got a virtual machine sitting in Discovered, and I'm just going to drag that into that folder. So imagine, obviously, if you sort of logging into vCenter and then deploying the virtual machine as the marketing administrator, you'd be able to do that. But I've already got the app in there, and you can see the developer role basically is the marketing role. So if I log back out of the administrator, I'm going to log in as developer 2. Again, you can only see, because I've logged in as developer 2, I can only see the VPC, so I can only administer that part. So what I'm going to do here is I'm going to create some connectivity. So I'm going to create a network. Okay, so I'm going to create, as I say, that logical switch. So you can see I've got a subnet here, add a subnet, give it a name. I'm going to tell it what type of network it is. So it's a public network, so we can obviously access it from the outside world. I only sort of need a small subnet to be able to do that. So I've created that network. So if I close that off, what I can then do is that network now will be offered up to vCenter for consumption. So you'll now be able to see, once I log out and log back in as developer 2, I'll see that network I've just created. And as I say, that's really where that then becomes available for me to consume and where I can place my VM onto that network. So you can now see web. So that's the logical switch that it's now created. And then what I can do with my web server is I can just edit the settings, change the network that it's connected to. And then I'm going to power on the VM. And then once the VM's up, what's happening in the background, it's connected to that logical switch, but there's also DHCP functionality on there as well. So there's a DHCP function as part of the VPC, which is giving the VM an IP address. Okay, so I'm going to go to this address 30.30.36, then complete the page. No access, not working. So it's not reachable at the moment. Because what I haven't got is I haven't got a security policy defined. So what I'm going to need to do is actually just go in as developer 2 and just add a policy. So again, very basic, create a new policy. I add a rule in there, which is just an any allow, and then I'm going to publish that rule. So now that as I say, gives me access to my web server. Okay. And again, this is all in the control of the developer itself, right? This is not the enterprise admin doing any of this. What I can then do is I can change that rule as well, so I can edit that. And all we're going to do here, again, something very simple, is just change the service from any to only allow HTTPS. Yeah. And then I'm just going to block everything else and move the rules around. So you can now see if I refresh that, it's just spinning, nothing's happening. If I then change it to HTTPS, I've now got access using HTTPS. Okay. So that completes the 2 demos that I wanted to show you, and that completes the end of the deck. So, any questions? Anybody want to ask anything? All make sense?
Can you clarify the distinction between the project and VPC?
Yeah, so
They look kind of like the same thing in the slides, but
yeah, so you get, if I go back, I've probably got a better slide that will sort of show you that. So ultimately the VPC, so if you sort of saw in the UI, under a project you've got access to more things. You can configure more things within the project. So I could create a tier 1 router outside of a VPC within a project and then peer that to the tier 0. So I've got a little bit more flexibility in terms of a project, in terms of what I can do and what I can configure. The VPC is obviously, I suppose, is just literally that small, that's that, right? So if I'm a VPC admin, all I get access to is this. But what I can have within a project, I can have multiple VPCs. Yeah, so basically, yeah. And there's 3 levels of admin here. There's the enterprise admin, there's then a project admin. So you could say, for example, I don't know, give the owner finance, somebody in finance, access to a project, and then they can then go in and then create, I suppose, VPCs for people within finance, right? And give them their own little enclaves. But yeah, ultimately, as I say, it's just 3 tiers of access. So enterprise admin, project admin, and then VPC admin. But yeah, you basically create the project create the VPC within the project. And then as I say, you've got a little bit more control over what you do within the project and what you can configure.
Will there be sort of better symmetry, synergies, whatever the right word is, between the way NSX has these constructs and vSphere? So vSphere's got namespaces when you implement supervisor plane
Yeah.
namespaces. Is there going to be some form of mapping?
Yeah, there will be. Yeah, I think there will be over time. Yeah, ultimately, yeah, sort of things like namespaces will come into projects and VPCs and things like that. So yeah, over time, I think as well over time, a lot of this will be done through vSphere. Do you know what I mean? I'm not saying that it's going away, but I think more and more will move into that centralized place of management, and a lot of this will probably be hidden away, right? It will just be, you go, okay, I'll have a project or a VPC, and then it will just go and do it. But yeah, I know that, and I've got a bigger deck on projects and VPCs. There's a much bigger deck we can go through, and we can sort of set some time to do that. But yeah, ultimately, I think a lot of this will be moved to SDDC Manager. I've got a stop, apparently. Yeah.
You mentioned, it's the first time I heard it, that the legacy load balancer is being kept for some special use cases.
Yes.
We've been on VCF since like 4.0. When you deploy it as per like standard, automation, operations, and identity manager all use the load balancer.
Yeah.
Now we were expecting to have to move away from that, but not sure what to replace it with. Now, don't you mention it's being kept for area automation,
Yes.
but not for the other products?
Yeah, so I think, so area automation, the IaaS control plane, and load balancing of VCF infrastructure components. So what did you say you're using it for?
Well, it's all, if you deploy out a lifecycle manager, you deploy a cluster, it automatically uses the load balancer for automation.
From NSX.
Yeah.
So I imagine, so you'll still use that.
For identity manager,
Yeah. So any sort of VCF infrastructure components, that's fine. It's ultimately not gonna. You can't use it as a server load balancer, right? You can't use it for workloads outside of the VCF infrastructure. Yeah. So that's. I mean, that's been. Yeah. This was literally 4.2. So this was new to a lot of people, right? When they announced basically the entitlement change.
You can't be sure what it's going to change to, because you can't deploy new with it. But if you're upgrading from with it, you keep it.
Yeah.
You're never sure how long you can keep it.
Yeah. So it's staying. I mean, ultimately, I think why they were going to get rid of it, because the view was that they would embed AVI into it. It's never happened, but it's based on an NGINX load balancer, and an NGINX are owned by F5, right? So they were then going to remove it and then put AVI in it, and it's never quite happened, but I imagine it's just going to stay. But yeah, for a small subset of use cases. Cool. Yeah. Well, yeah. Don't know. Not as yet. Yeah. Cool. Okay. Thank you. Thank you for your time. Cheers.